Good evening, everybody, and welcome to prereq level math for college level mathematics. And we are recording for quality purposes, so don't do anything rash. I just want to do a little quick recap about last lesson. We learned how to multiply polynomials using the distributive property, and we also learned how to FOIL multiply polynomials using FOIL method, box method, or tower method like you would use in elementary school. And then we went over factoring out GCFs, just the very basics. So today, I would like to go over factoring trinomials, and then we're going to be also factoring GCFs with them. And then I just want to go over factoring polynomials of 4 with GCFs. And we're going to learn how to factor by grouping today. Yay. I mean, we're not going to, in this level class, I'm not allowed to actually teach how to divide polynomials because it requires long and synthetic division, right? Okay, so let me pull out my whiteboard. Okay, so we're going to continue on with factoring polynomials. Okay, so we're going to factor by grouping. So that means factoring by grouping requires the same result inside parentheses for one common factor of the polynomial. So, for example, what if I factor the polynomial x squared plus 5x plus 6? Well, all I need to know for this is just AC method, right? So what I do to factor this kind of polynomial, I take all the factors of 6 that add up to 6. So I can say that 6 is 1 and 6, right? And we have 2 and 3. And now, this is key to know. AB is equal to the factors of this term that add up to the leading coefficient I think it's 2x, right? Of middle term, which is also known as A plus B, right? So look at this, guys. This works like magic because you see, look at this. 2 plus 3 equals my middle term 5, right? Sorry about that. I didn't draw a perfect circle. And look, I secretly know that this is x plus 2 times x plus 3. That's because I'm well experienced with this, guys. I've known this since 10th grade. But if I could do this by splitting up the terms, I have x squared plus 2x plus 3x plus 6, right? And now you factor by grouping. So what you can do is take an x out of an x squared and another x plus 2, and then you add 3, and then you get the same result in the parentheses. Now this is key, guys. You have to have the same result in the parentheses, because if you don't have the same result in the parentheses, you don't have a common factor of a polynomial, right? So in all, this polynomial factor down is x plus 2 times x plus 3, right? See that? It works like magic. I love the AC method because it's my favorite personally. So on your mark. So we're going to factor the polynomial. Let's just go over one that's easy, like x squared minus 4x plus, let me think for just a second. I don't think 8 would work because it factors in. Yeah, let's make it 6. Because you know what? If it's x squared minus 4x plus 8, that would make it a prime polynomial. I'll show you that. I'll show you guys that in a minute. 6. Let me think. That factors into 2 and 3. Yeah, that doesn't work. I'm gonna erase this. X squared minus 4x, not z. Would 10 work? 10 factors into 2 and 5, and that adds up to 7, doesn't it? Actually, let's make this a little more interesting. X squared minus 7x plus 10. All right. What we're going to do, we are going to check this and see if we can factor it by using AC method. So we have A times B. We have A is 1, B is 10. But look, pay attention to this. You have a minus sign, so these have to both be negative, right? And then you've got a -2 and a -5. And look, this method really works like magic, guys. Because you know what? -2 plus -5 gives you a -7 in the middle, right? So then if we could split this up, x squared minus 2x minus 5x plus 10. And look at this. I take an x out, and I take another x out, subtract 2, right? And then I take out a -5, and take another x out, subtract a 2. Look at that. Guys, I just want to point out something just really quick. You got to have the same exact result in your parentheses. You got to remember that. So this polynomial factored down completely is x minus 5 times x minus 2, right? This is your factored polynomial. Ooh, get set. Now we're going to factor one that requires a GCF. Let's say we have 3x squared minus, let's see, 12x minus, you know what? I'll try 15. So 15 factors into 1, 15, 3, and 5. Okay, 15 is not going to work. 1 and 18, 2 and 9. Ah, so close. 21. Okay, so we got 3 and negative 7. Because I think the bigger one would have to be negative if you got a minus right here. Trying to think of a good one. Let's try 24. 3 and 8. 3 minus 8. Oh, which gives me negative 5. Okay, I got a good one. Let's make this a negative 6x. Okay, so if I take the factors of negative 27, one of these have to be negative. And look, if the minus sign is right here, then I think the bigger one would be negative because you've got, what is it? 1 and negative 27. 27 doesn't go into 2 evenly, so 3 and negative 9. And guess what? 3 and negative 9, you don't need to factor any further. It adds up to a negative 6, okay. So, let me actually denote that. Ooh, orange. Now, you guys need to be careful here because pay attention to your leading coefficient of the polynomial. You've got a 3x squared plus 3x minus 9x minus 27. And you've got 3x times an x plus 3. And you have a minus 9 times another x plus 3. And you got to remember, the terms in the parentheses have to be the same. And 3x minus 9 times x plus 3. You think this is completely factored down if you have to factor out a GCF? No, it's not. See, 3 and 9 have common terms alike with each other. You got to take the GCF of what's inside this here. So I can say that the GCF of this polynomial is 3, right? I can say that it's completely factored down as 3 times x minus 3 times x plus 3. That's our final answer right there. You got to pay close attention to this because if you have two terms that are multiples with each other, you factor out the GCF, right? This will give you guys a taste of when you have a negative leading coefficient, which we will talk about in the next lesson, where these kind of polynomial factorizations have a negative leading coefficient. Okay. Let's go. I'm going to give you guys a I'm going to give you guys a multiple variable one with different variables. So what if we had, let's just do the leading coefficient as 1 right now with the multiple variable one. So what if we had m squared n minus actually let's make that m squared minus 5mn plus 6n squared. What do you do here? Well, it's pretty simple. You can still use the AC method, right? It even works with these multiple variable polynomials. So you've got, I'm just going to factor 6 all alone. I've got 1 and 6, and 2 and 3. And guess what? Pay attention to this minus sign. Both of these are negative, right? Both of these are negative. This method really works like magic. Purple. Sweet. Because look, all you got here. Now you got to be careful when you're using this method and you have these multiple variable polynomials. This is m squared minus 2mn minus 3mn plus 6n squared, right? And then we factor out by grouping. So I can take out an m and another m, subtract 2 times n, right? Subtract out 3. And we've got, no, that's 3n. Sorry, guys. Be sure I'm doing my math right, people. We have another m minus 2n. Look at that. Voila. We got the same exact thing in the parentheses, because if you're not getting the same exact thing in the parentheses, you guys need to go back and check your work, right? So now, our completely factored out polynomial is m minus 2n times m minus 3n, right? I only give you guys these multiple variable polynomials just so you guys are aware. Because we may be dividing polynomials that have multiple variables when you reach college algebra level, right? Okay. Now it's your turn to practice, guys. Now it is your turn to practice. I would like for you guys to factor, I should cover these. I'm going to let you guys factor the polynomial. Let's go with a different variable other than x. How about, ooh, p is a good variable. P squared minus, let's make that a plus. P squared plus 4p minus 16. Here, let me get my calculator out. I shouldn't have to tell you guys this. I shouldn't have to tell you guys. Actually, let's make that plus a 10p minus 24. And then I want to give you guys one that requires a factorization of a GCF. So how about 4t squared? Let's make that minus 8t plus, I don't know, 36. Yeah. Oh. Ooh, let me make this a little better. Let's make that a minus 20t. That one will require a GCF. That's a hint right there. And then I want to give you guys a multiple variable one as well. So like maybe squared minus 3. Let's make this a little easier. 3fg plus, let's just make those all pluses. I don't want to pressure you guys too much. So plus 2g squared. Because how would it be factorable if I didn't include the g squared at the end of the 2? Okay, go ahead and feel free to give these a try. I will go through some calculations. Yep, that one works. Okay. I will be right back, guys. Drink water. I just realized I'm down to 84% on my battery on my computer, so I gotta plug it in. I will now be quiet, guys, so I just need that. Pardon me. I'm going to give you guys about another minute if you need more time with this. And if anyone's confused by this notation right here with the caret symbol, that's because I'm on the computer and the computer can only do certain things. You guys feel like you're good? This feels pretty easy, doesn't it? But it's really not. But I want to show you guys one thing really quick before we go on to like checking your understanding. Like what if I had c squared minus 3c is 5? I mean, I can still check using AC method to factor this polynomial. So, in fact, I know 5 is a prime number. 5 can only factor into 1 and 5. Does A plus C give me -3? -1 plus -5 is not -3. Because look, if I try to split this up, say c squared minus c minus 5c plus 5. But see, I wouldn't get the same exact thing in the parentheses because look, if I just try AC method and I do like c times c minus 1, then I subtract 5 out, and then do another c minus 1. Oh, but -5 times -1 gives me a -5. +5. But, yeah, I'm going to have to check this one on Desmos. Just really, really fast. Desmos, I have to plug x's in. So c squared is x squared minus 3x plus 5. See? Because if I try FOIL multiplying, if I try in x minus 5 times x minus 1, I mean, look at this, guys. The graph does not match. See that? Because that would give me a -6c rather than a 5c. So in all, and don't get thrown off by this, but as you can see, this polynomial is prime, right? If the graphs don't match when you check it on Desmos, it's a prime polynomial. Just so you guys are aware, right? And there's even some higher degree polynomials that are prime as well. But anyway, let's get into checking your understanding of this. This is going to be a 4-question evaluation. I'm not going to say it out loud. So Good luck, guys. Just test your knowledge by taking this 4-question evaluation. And just to give you guys a helpful hint, you can use your FOIL multiplying skills to check your work and be sure you get the same result of the polynomial given to factor. And I also give out multiple variable polynomials, that way you guys are aware, right? Do you guys think you had enough time? Maybe 2 more minutes. I'll give you guys 2 more minutes if you need more time. because then we're going to move on to polynomials of 4 terms. Um, oh, I thought I saw somebody join my meeting for a second. But anyway, let's move on, guys. Okay. Factoring by grouping. Polynomials of 4. Oh my goodness, guys. It's going to be a little bit more tricky here. Because look, you still do the same process, but it's just going to be a little bit harder. So still the same process as factoring basic quadratic trinomial using AC method, but a little more tricky. Okay. What if I factored the polynomial x cubed minus 2x squared plus x minus 2? Well, you can't really split up the 2x squared and the x's. You got to be very careful here. Because look, you can still factor these by grouping, right? So you can group the x cubed minus the 2x squared, close that parenthesis, and put an addition symbol, and put the x minus 2 in the parenthesis, right? So then I can take an x squared out of an x cubed, right? I can take an x squared and an x out of a cube, do x minus 2. And this is just 1 times x minus 2, but I am going to denote the 1 in case anybody is confused. So then this polynomial factored completely is x squared plus 1 times x minus 2, right? You got to be very careful because AC method is not worth using when factoring polynomials of 4 like this, right? But I do want to point out something to you guys. What if you had a factor of x squared minus 1 times x minus 1? I'm going to teach you guys how to factor this a little later on. because we are going to get into difference of perfect squares and perfect cubes. But this is the last thing needed to know before we get into difference of perfect squares and perfect cubes, because that will be Wednesday. And then hopefully we get into solving quadratic equations just by factoring, just basically by factoring. But as you can see, this polynomial is not completely factored. But I am going to tell you this, guys. X squared minus 1 can factor into x minus 1 times x plus 1. But we will get into this a little later, right? Or you can say that this is, in simpler terms, x minus 1 quantity squared times, I should put a multiplication symbol there. This is the computer I'm writing on, right? Just to make this a little simpler, using exponents, using like exponential notation, you can say this is the quantity of x minus 1 squared times x plus 1, right? And then I'll be teaching you guys some shortcuts to squaring and cubing polynomials as well on Wednesday. That's something else we'll go over. We'll learn how to square and cube polynomials, but we're just going to keep it simple with just binomials like this, right? Because you can see that this polynomial on top is not completely factored. That's why I did this. But we are going to get into something like this later on. We will get into this Wednesday, like I said. But anyway, this is your completely factored polynomial for this polynomial of 4, right? Okay, time to move on. On your marks. Okay, say we wanted to factor the polynomial e cubed minus 4e squared plus e minus 4. Okay, here we go. Just group the polynomials in half first, like that. Put your little famous addition sign in there, right? And then look, I can take a d squared out of a cube. I can take a d squared and a d out of a d cubed, right? And then you have just plus 1 times d minus 4. And again, you have to have the same exact result in the parenthesis, right? Or else you don't get a common factor if it's not the same result in the parenthesis. So this polynomial factor completely is d squared plus 1 times d minus 4, right? I mean, it even works like magic when you factor a 4-term cubic polynomial like this, right? Okay. Get set. Okay. So let's do one like maybe okay. Um let's do one with the leading coefficient of more than 1. So how about 3f cubed minus 6f squared plus 2f minus 4. This one should be easy enough because if I made that like a 6 on the end, that would require long and synthetic division to factor. And we're not going to get into long and synthetic division, thankfully, in this prereq level class, right? Now, I actually, you know what? Let me make this a little better. I like to do one that requires a GCF, actually. So let's do 3f squared minus 3f cubed minus 6f squared plus, let's see. Let's try 12f minus 24. 24 divides into 3, right? The first one I need to do, and in this case, it's easier for me to understand if I factor out the GCF first, right? Because these polynomials are a touch harder than quadratic to factor, right? Their GCF is 3, right? So you got 3 times f cubed minus 2f squared plus 4f minus 8. Look at how much easier this is now. Now I can factor these by grouping again so that I can't forget this 3 out here. I can't forget that scraggly 3. I can group my f cubed and my minus 2f squared. And I can also group my 4f minus 8. Ah, but look at this. Here's another GCF to factor out right here. See that? But I'm actually going to save that till the end. So what do we got? 3 times f squared times f minus 2. And look at that. I can factor out the GCF right here. 4 times f minus 2. And I get the same exact result in my parentheses. So we got a common factor. So now we got the scraggly 3 outside times f squared plus 4 times f minus 2. And that's completely factored right there, right? But I also wanted to point out tomorrow on Wednesday that we are going to go over factoring these, but with negative leading coefficients, right? Okay, let's go. Okay, how about one of these challenging ones? Let's try AC minus BC plus AD minus BD. Ooh, what do I do here? What do I do here? Okay, it still works about the same way because you can group your ACs and minus BCs, close parentheses. And you can group your ADs minus your BDs, right? So all you're doing is just saying that this, you can factor out a C here. You've got A minus B plus B times another A minus B. And look at that. I would like to alphabetize these and say that this is A minus B times C plus D, right? I like to alphabetize my letters, but Even if you guys, even if you wrote it this way, C plus D times A minus B, I don't care. Because you know what? Guess what? The magic about this is that A minus B times C plus D is equal to C plus D times A minus B, right? They're both the exact same, right? And if I could put this into a fact family, look at that. AC minus BC plus AD minus BD is equal to C plus D times A minus B, right? And then to finish off the fact family, you have AC minus BC plus AD minus BD is also equal to A minus B times C plus D. And this little interesting fact, this is your fact family, this polynomial, right? Now it's your turn to practice. So you guys can see that problem. Some little old math here and see if 72 is divisible by 3, and it is. I just wanted to give you guys one with a GCF. That way I could really challenge you. Ooh, I've got a good one. Let's make it with leading coefficients of more than 1. Here we go. Here we go. Okay, this will give you guys a chance to practice what you've learned. Good luck. Give these a try. And in case anyone's confused, I will denote this. V caret 3 is actually V cubed 4 to the 3rd power, right? I shouldn't have to do the squares anymore. But V cubed is denoted as this. V cubed or V to the 3rd power, right? Okay, well, since I forgot to mention, I forgot to go over these answers in the last one. I am so sorry about that, guys, but little dumb me. But I'm more than happy to go over these ones with you guys because you know what? The factoring by grouping, considering cubic polynomials like this, are a little tougher. So I'm happy to go over these. So if you got b cubed minus 12b squared plus b minus 12, you just start grouping. B cubed minus 12b squared can go inside parentheses plus another b minus 12. And let's factor all this business here. I can take a v squared out of a v cubed, and I've got v minus 12 plus 1. I get v minus 12 again in the parentheses. And look, the magic about the exact result in the parentheses is a common factor. So the correct answer for the first one factored is v squared plus 1 times v minus 12, right? Clear all this business that way I have enough room to write. Okay, so 3y cubed minus 9y squared plus 24 minus 72. Ooh, look at that, guys. You got to factor out a GCF here. Your GCF is 3, right? What do you got if you factor all this business out? 3 times y cubed minus 3y squared plus 8y minus 24, right? And then you factor all this business inside the parentheses. So you got the scraggly 3 outside. You got the scraggly 3 sitting outside in the cold, outside of the parentheses, right? Because it wasn't on his best behavior. And I'm just going to leave it this way in case anybody's confused on this. And the 3 doesn't escape out of the parentheses, right? I messed up, guys. That isn't y squared. Sorry about that, guys. 3 stays outside. I was thinking this was a quadratic for a second. Sorry about that, guys, but this is a cubic. I got to pay attention, right? I mean, this is more than just a quadratic. It's a cubic inside this parenthesis, right? What do you have? 3 times, you can factor out a y squared out of a y cubed. You can factor out a y squared and a y out of a y cubed, and you got y minus 3 in the parentheses plus. The GCF of this polynomial is 8. That's already grouped, and you still have that y minus 3. And look at that. Just by factoring out the GCF, you get the same exact result inside the parentheses. Like magic. I mean, a GCF works like magic, doesn't it? So your correct answer for number 2, the second one, you got the scraggly 3 sitting outside. You got y squared plus 8 times y minus 3, right? And you got to remember to factor out the GCF, right? And now this one, 4wy minus 8wz plus 4xy minus 8xz. Let me get my famous eraser out. That way I have room to do my work. Okay, so I need to think about this one. This one requires a GCF as well, right? So I can say that the GCF of this one is 4. I can say that this is 4 sitting outside times WY minus 2 WZ plus XY minus 2XZ, right? That's why I factor out the GCF. And now you got to be very careful here, because this is where I see students making a mistake. They actually factor out a Y instead of a W here, right? They say this is, oh, this is 4. But first I'll show you that in just a second, guys. I will point that out to you guys in just a second. Oh, I'm supposed to group these. Come on, computer. Close this parenthesis here. Now this is where I see students making a mistake. Oh, I can factor out a Y and say this is W minus Z, when a minus 2Z. And see, Y times W gives you YW, but does Y times Z give you YZ? No, it doesn't. This is where I see students making mistakes. Because you see, W is supposed to go outside, and this is actually W times Y, which gives you WY, and this is minus 2Z, right? W times Y gives you WY, W times 2Z gives you 2WZ. And then you've got plus 1. But then people think, this is where I see people making, or students making mistakes, and they say, oh, this is plus 2 times Y minus 2Z, right? But hey, look at this. 2 times Y doesn't give you XY. And 2 times a negative 2Z doesn't give you a minus 2XZ, right? So this is actually plus Z. No, that would give you Z squared, wouldn't it? Plus X. And look, X times Y gives you XY. X times 2Z gives you a minus 2XZ, right? I just showed you where students commonly make a mistake, right? So in this case, we had to factor out a GCF. So we got 4 times W plus X times Y minus 2Z, right? This is the correct result. Because look, really, a common mistake I see students make is that they think that the group polynomial, if you have WY minus 2WZ, they just factor out a Y and do W minus 2Z. And see, Y times W gives you WY, but does Y times 2Z give you a minus 2WZ? See this? The W is misplaced. See? If you look at this very closely, this is not the correct factor of this polynomial, right? And then students actually factor out a Z, and that's W minus 2Y, right? which is also not true. That's also not true. See that? Because z times w gives you zw and not wz and not wy. And z times a negative 2y gives you a negative 2yz and not a negative 2wz. So this is way wrong. See that? Huh. Okay, let's get you guys evaluated on this now by checking your understandings. I might be kind of sneaky in the check your understanding, so just be aware. I might give you guys something beyond cubics and be kind of sneaky here, right? We try to even not use u because u can actually be used in u substitution. I'm gonna be kind of sneaky here. Accept it. There you go. Ha ha. This is gonna be a trick question. Good luck here, guys. And just so you know, I'm just gonna point this out to you in case you're all confused by these new things here. Right? I need to write a better R than that. I'll try to be quiet while you guys do this evaluation, though. I just shouldn't have to do the cubes and the squares because you guys pretty much know that, right? Without me having to write down with in case you guys are confused. Because you're well experienced with cubes and squares, right? There you go. just because I was kind of sneaky on question number 4, right? I apologize, everybody, but I was kind of sneaky on question number 4. And if you need a little bit more time, I'm going to give you guys another 5 minutes. In case anybody's confused on question number 4 of checking your understanding, I'm sorry, but I'm kind of sneaky like that sometimes. And just look at the sides if you're confused by the caret marks. It's the first time I've ever given out a 7th and a 6th power in this course. That's why I included the writings of the 7th and 6th powers and 5th powers. Right. I did include a writing of a 5th power once, but I've never included a writing of a 6th or 7th power. Just look to the side. Boy, seventh powers would be massive numbers, if you ask me, right? I mean, what's 9 to the 7th power? Isn't that pretty massive? Just by looking at a calculator, I'll tell you guys what 9 to the 7th power actually is. 9 raised to the 7th power. Oh boy. Yes, 9 to the 7th power is a very massive monster number of 4,782,969 when I look at the calculator. Holy crap. Holy shit, that's a big number. Pardon my language, but you know what? This is college you guys are in. I'm allowed to cuss. It's part of the criteria to cuss in college, right? So do you guys really feel weak for my physique on this fourth one right here? Like I said, I'm very sorry if you guys are really confused. That's why I'm giving you guys a lot more time on it. About one more minute, guys. We have to move on. And if you guys are really, really confused on this fourth one, you can pause the video and give it a try. Only if you're watching this on YouTube, right? But if I post these publicly, I protect them by copyright. That way people don't steal my information. Go ahead and let's move on. Okay. So I also wanted to point out that when we factor these kind of polynomials, when they have negative leading coefficients, I'm just going to go over the trinomials. So I'm going to say factoring trinomials with negative leading coefficients. Okay, so the factoring process is the same, but you factor -1 out of the polynomial, right? So for example, What if I gave you guys negative x squared minus 5x minus 6? Well, what do I do when I have a negative leading coefficient? Like I said up here, you factor out a -1, right? So you've got -1 times x squared minus 5x minus 6, right? But can I factor out this polynomial even further? Even though you factor out a -1, you still got to factor completely, right? It is key. I'm going to say a note. Factor polynomials completely, right? By college level, you guys need to factor your polynomials in only linear terms, right? I'm begging you guys to factor these completely, because you know what? If I give out the exam in one Zoom meeting and I see that a polynomial is not factored completely, I'm going to dock points off of the exam, right? So if I factor -6, I'm checking this by AC method. And if the negative sign is in the middle term, the bigger one is negative, right? So 1 and 6, no, 1 and -6 rather, 2 and -3. Hey, look at these. I just gave you another example of a prime polynomial. Because you know what? Even though this has a negative number outside, it is still prime, right? So, on your marks. Let us factor the polynomial negative x squared. How about plus 4x? Let's see. Let's see if I can come up with one that works. The negative sign kind of fools me a little bit. What if I did -10? No. Plus 10? Plus 12. Oh, there we go. Okay. Okay. So negative x squared plus 4x plus 12. That's a good one right there. So when I have a negative leading coefficient, I factor out a -1, right? Sorry, guys, I'm just checking Desmos on my phone. I'm only using Desmos because it's a little tougher for me to think when we're getting into factoring polynomials like this, right? Okay, so we take the factors of -12 using the AC method. And look, the negative sign is in the middle term, so the bigger one is negative. So if you're factoring a negative number, one of the numbers have to be negative. So let's see, 1 plus a -12 gives me a -11, so that's not going to work. So 2 and -6. And that's 2 plus a -6, which indeed gives me a -4. So I am going to circle this in green, which factor works, which factor satisfies this polynomial, right? So I'm going to do about the same process. Leave this -1 outside, leave that unhappy -1 outside, right? X squared plus 2x minus 6x minus 12, and close that parenthesis. So you got a negative 1 times, I'm going to factor out an x, and I've got an x plus 2, factor out a 6, and take out another x plus 2, close that parenthesis, and then I should get negative 1 times x minus 6 times x plus 2, right? You got to be careful, guys, because when you have a negative leading coefficient, you have to factor out a negative 1 first, right? Get set. Okay, let's factor out 1 with an even deeper negative number for a leading coefficient. So how about a negative leading coefficient and a GCF? So what if I did a negative 3x? Let's make this a little more interesting. A negative 4x squared plus, let me get my bearings straight here. So 4x squared oh, here's a good one. Plus 12x plus 40. I just had to think of a really, really good one. So what I do, I again factor out a negative 1, right? Times 4x squared minus 12x minus 40. Because when you're factoring out a negative 1, you have to change the sign, right? It's key when you're factoring out a negative number, you change the signs. So here's the key. Here's the catch. When factoring out a negative number, you change signs in all terms, right? And then the next step is I take the GCF of this polynomial, right? So I got a negative 1 times 4, which is the GCF of this polynomial, right? X squared minus 3x minus 10. Yep, if I did my math right. And then this makes it so much easier because if you didn't have GCF method, you would have to like use rainbow and reduce method. You have to multiply this a term times the c term and get the factors of that whole a times c term. The factoring out the GCF makes this so much easier. My gosh. So factoring a negative 10, and again, pay attention to the sign in the middle. And if the sign in the middle is a plus, the smaller one is negative. But if the sign in the middle is a minus, the bigger number gets the negative sign. So you got 1 and negative 10 because the bigger number gets the negative sign, right? Because this negative sign is in the middle term, so the bigger number gets the negative sign. So 1 plus a negative 10 gives me a negative 9, so that doesn't work. 2 and negative 5. 2 plus a negative 5 gives me a negative 3. Sure enough. Then I just do my good old-fashioned grouping, right? I just do my good old-fashioned grouping of the polynomial. So then you've got this -1 outside and this 4 outside because we factored out a GCF. And you've got x times x minus 5 plus 2 times another x minus 5. And you got to remember, terms in the parentheses, when you factor, have to be the same. Because if they're not, then you got to go back and check your work, right? So what do you got? If I multiply a -1 and a 4, I get a -4, right? If I just combine those together, times x plus 2 times x minus 5. So what I've got here for this final result for factoring, I have a negative sign because of the negative leading coefficient. I have the GCF outside, and I have my factored polynomial, x plus 2 times x minus 5. See that? I mean, that's what a GCF is for, man, to like make things a lot easier. But there are some polynomials like this that are not going to work with GCF method, and I will show you guys that in a future lecture, which I will show you Wednesday. Right? Let's go. Let's do a multiple variable one. We're just going to do a leading coefficient of 1 to make it a little easier. But this time the 1 is going to be negative, right? Because we're doing these with negative leading coefficients now, right? So if I have a negative f squared, let me think, f squared, let me think of a really good one. Negative f squared minus 6fg plus 16g squared. How about that one? That one looks good. That way because you can't factor if it's factors of like decimals and fractions. I mean, you got to avoid factoring a decimal or a fraction, right? You got to avoid like factoring rational numbers, especially, right? So you got negative f squared minus 6fg plus 16g squared. Again, you factor out a -1, right? Change the signs in each term. That's key, right? Because if you're factoring out a negative number, you have to change the signs, right? I mean, it wouldn't make sense if you factored out a negative number and you didn't change the signs. Now, this is a common mistake I see students making right here. This is a common they think that, for example, if I give out like negative y plus 3, they think it's a -1 times y plus 3, right? And that's not true because a -1 times a +3 gives you a -3, right? And now let's get to factoring this business. I'm still going to use AC method. So we got a -16, and the middle term is positive, so the smaller factor gets the negative number. -1 and 16. And I believe that is positive 15, so that's not going to work. Negative 2 and 8. Negative 2 plus 8 gives me a positive 6, so I'm going to circle this in purple. Ah, didn't mean to do that. Sorry, guys. I'm going to circle the factors that work in purple. See? And then you got the negative 1 sitting outside. Then I split up my terms, minus 2f plus 8f. No, f squared minus 2fg plus 8fg, because this is multiple variable. 16g squared. Okay, so we've got a negative 1 times f we can take out. We can take out an f minus 2. And then we have a plus 8 times another f minus 2. We'll close the parentheses. And look at this, guys. Voila. You got negative 1 times f plus 8 times f minus 2. Right? And if you have a negative leading coefficient, you factor out a negative 1 first. I mean, there's other common mistakes students make when you have a negative leading coefficient as well, but I don't have the time to show you that because I've only got 2 hours. I've only got about 2 hours to teach, so I'm going to give you guys a little bit of time because it is now your turn to practice these. Okay. How about you guys give those problems a try? And we are kind of short on time, so all we got to do is just get through an evaluation on this lesson, and then I got to give you guys a pop quiz before we go. Right. I need some more water. And these past few minutes have felt kind of brutal, so I might have to go to the bathroom. I will be right back, guys. But feel free to give all of these problems a college try. Okay, you know what? I hope this gave you guys enough time because this is going to go in a little bit of overtime. So if you want to, I can actually go over these. So what you're just doing, I mean, all of these you can see have negative leading coefficients, right? So like for instance, in number one, if I've got a negative x squared plus 7x minus 6, first what I do, factor out a negative 1, and then change the signs, minus 7x plus 6, right? And then I check by using AC method, 6, and then this middle sign is negative, so both the factors get negative signs. And guess what? Voila. -1 and -6 are the factors of 6 that add up to -7. So we've got a -1 x squared, split up my terms, x minus 6x plus 6, close the parenthesis, and then we get -1. I can take out an x, and I've got an x minus 1 minus 6 times another x minus 1. And look at that, I get the same exact thing in here. Calculators may not include the negative sign in it, but I am including a -1 in it just in case anybody's confused. I mean, I'm including the 1 after the negative sign for quality purposes, right? So the correct answer for this first one is -1 times x minus 6 times x minus 1, right? Clear out my board here. Okay, so if I have a -6x squared minus 18x plus 24, first, as usual, I will factor out a -1. And important, you change your signs, plus 18x minus 24. And I got to factor out a GCF, don't I? So you've got -1 times 6, which is the GCF, times x squared plus 3x minus 4. Look how much easier that got. And if I factor out a -4, and just because the middle sign is positive, the smaller number gets the negative sign, right? And I take -1 plus 4, I get a +3. So then I have a -1 times 6 times x squared minus x plus 4x minus 4, right? And then I have a -1 and a 6, which are my two, which is my GCF is the 6, but it's my GCF altogether once I multiply those. X I can take out, another x I can take out and subtract 1. And then we have plus 4 times another x minus 1. And you got to be sure the terms of the factors in the parentheses are the same. So really the correct answer for this one should be, I have to multiply -1 and 6, which is really -6 times x plus 4 times x minus 1. I don't care if you guys leave the -1 out and the 6 out, as long as you have the GCF with it. But the correct answer for the second one should be -6 times x plus 4 times x minus 1. Right? Now onto a multivariable one. Okay, so if I have a -x squared minus 8xy minus 12y squared, first I factor out a -1. X squared plus 8xy plus 12y squared, right? So then I have to use AC method to, to factor this, right? So we got 12, and both signs are plus, so you don't need to worry about any negative sign because none of the factors are going to get negative signs if the middle term is a plus and the ending term is a plus. So the factors of 12 are 1 and 12, right? 1 and 12 add up to be 13, so those are not going to work. 2 and 6? Yeah, 2 and 6. I am going to circle this in green. 2 and 6 are the factors that add up to 8, right? Because this is A plus C. So you've got a -1 times x squared plus 2xy plus 6xy plus 12y squared. Close this parenthesis. And now you've got a -1 times an x times x plus 2y, right? Because this is multiple variable, plus 6 times x, no, that's 6y times x plus 2y, right? Sorry, my brain is like really fried, man. So what do you got? A -1 times x plus 6y times x plus 2y, right? The correct answer for number 3 is -1 times x plus 6y times x plus 2y, right? Let's get you evaluated on this now. And evaluations are where I'm not going to go over the answers. This is kind of like a quiz, right? I know we're a little bit over time, but I still have to give out a pop quiz as well. Actually, let me change the variables. There we go. Okay, good luck, guys. Best of luck. I'm not going to go over answers because this is like a quiz, like I said. Okay, guys, about one more minute on this check your understanding evaluation. All right, so I think that should do it. But I did want to show you guys something really, really quick. Even if you have like polynomials of 4 and you've got a negative leading coefficient, it works about the same way. I mean, I don't have a whole lot of time in the semester to go over this, but like, I'm just going to give you one really simple. Like, what if you had a negative x cubed? Cube is a 3 plus 2x squared minus, how about x plus 2? It works about the same way here. What you do, you factor out a -1. Keep thinking these are quadratic. And it's important you change your signs if you factor out a negative number. Pay attention to this negative sign. This negative sign changes the signs, right? And then you just factor this by grouping. Group your terms. Damn it. And then you just do the process of factoring, right? But really, this is just the negative sign all by itself. I mean, that's the way math way would show it, right? The negative sign all by itself. But just not to leave you guys confused on this, I will include the one in another version, the factored polynomial, right? I need not to leave you guys confused. That's why I put the one in with the negative sign, right? But really, it should be the negative sign without the one, because one is the loneliest number that you'll ever do, right? But I do include the one in case some of you guys are confused by this right here, right? Okay. Guess what time it is? Haha, gotcha. It is time for a pop quiz. Here we go, guys. This is it. Get ready. Gotcha. was gonna be sneaky, wasn't I? But I'm not. I'm not this time since it's a quiz. You guys are so used to acting the variables a little bit. There you go, guys. I included the one where I've been kind of sneaky on that check your understanding as a bonus question this time. So good luck, guys. I'm gonna go run to the bathroom really quick, guys. Okay, I think that gives you guys enough time to get this pop quiz done. I do have a ticket out the door question for you since we've learned so much. So your special ticket out the door question is this. I'm choosing one in my head out of random, but what we've talked about. And this ticket out the door question is over FOIL multiplying. Okay, your ticket out the door question, 5 minutes. Good luck. Hey Siri, set timer for 5 minutes. Three more minutes, guys. 2 more minutes. And if you just answer this one question, you are more than willing to leave this Zoom meeting. Just answer this question and you are dismissed. Got about a minute left. All right, guys, time is up. That is all we have for today. I will stop my share. So before I leave, guys, I will be teaching again on Wednesday, and I'm only going to teach one day next week due to the Thanksgiving holiday. So what we will be getting into tomorrow is factoring difference of perfect squares and perfect cubes. And then hopefully by next Monday, we can actually get this first exam in. Other than difference of perfect squares and cubes, we're going to go over solving quadratic equations using just the factoring method. So just hang tight in there, guys. Just be safe, make good choices, don't get arrested. And I'm signing off now, guys. Have a great day. Bye bye.